This video is going to look at what's going on inside of the nucleus, specifically with the protons and neutrons. We have isotopes of atoms that are not as stable as our naturally occurring isotopes, and that is what we see with nuclear decay. When you are looking at a nuclear equation, and we're not going to spend a whole lot of time on these, you only see the changes that are occurring in the nucleus, so you see your atomic number and your mass number. And we see that it still has to be balanced just like it was in our original equations, where we have to have the same number of protons on both sides of the equation as well as protons and neutrons. Reactants are still on the left, products are still on the right. What we're going to focus on in this video is three types of nuclear radiation, and what are the differences and similarities between them. The first one we're going to look at is alpha radiation, and alpha radiation is basically a helium nucleus being emitted. It reduces the number of protons and neutrons each by 2, and because protons are positively charged, when a helium nucleus is emitted from the atom, a +2 charge is released as well. This is a common way for really heavy isotopes to reduce their proton to neutron ratio, and that just helps them to be a little more stable. We see that alpha radiation is not capable of a whole lot of damage because it is difficult to penetrate. A sheet of paper will keep you from being affected by alpha radiation. So alpha radiation is not something you really have to worry about when you go and get x-rays done at the hospital. Beta radiation is a little more significant. In beta, a neutron is transformed into a proton. And because of that, a neutral particle has become positive. When it releases a little bit of energy from the nucleus, it does have a slight charge, and it's similar enough to the mass of an electron that we represent it as an electron with a charge of -1. Beta radiation will not be stopped by a sheet of paper. You have to have aluminum foil separating the radiation from whatever it is trying to impact. So it has a little bit more significance. You're going to need something a little thicker than paper to be able to stop your beta radiation. Our last one is gamma, and this is the one you really have to worry about when you go and get x-rays done, which is why they have you wear the lead blankets. These are high energy photons of light. Your proton number and your neutron number aren't changing in your nucleus, but it's a way to release excess energy so that hopefully it's a little more stable. And when that energy is released, it can penetrate through paper, it can penetrate through aluminum. It is shielded both by lead and concrete. And concrete's a little bit heavier to wear, so that's why you wear pads with lead when you're getting x-rays done if you only have to have a certain area being x-rayed. So another way to look at this, you can see how the alpha is stopped by the paper, beta goes through that but is stopped by aluminum. Gamma goes through the first two, but is stopped for the most part by lead. It is stopped. I'm not sure why that line kept going out. I think whoever made that picture, I didn't pay attention to it earlier. I should have taken that off. Another thing to look at would be the one that's below there. You can see how alpha is stopped by your skin. Beta can get through your skin and would probably stop at your bones, where gamma can go all the way through your organs, so that's the one that's of a lot greater consequence. There are other particles you can run into, positrons, and those are ones that we would get into in a more advanced chemistry class. So if you had a radioactive source and it was coming out of a lead block and there was a charge in that force, you could tell the direction in which the particles would travel because opposites attract. So your positive protons, which are what we see in the helium nucleus, the alpha radiation, positively charged, would go away from the positive side of the electrical field and would go towards the negative side. Our beta particles, which are negatively charged, would go away from the negative side towards the positive end. And then our gammas, which don't have a charge, would go straight through. And that is the end of our radiation video. This one is short and sweet. I just need to make sure that you understand the difference between alpha, beta, and gamma radiation.